Today we are going to look at a problem from the book. It's going to be on page 41. This is number 28. We're going to talk about a few things. Number one, we're going to talk about what a contingency table or a two-way table is, how to read it. We are also going to talk about conditional distributions and marginal distribution, how to find them, what do they involve with the table, and then finally we're going to talk about what independence means. Okay, let's get started. When dealing with a two-way table, one of the things you're going to be given typically is just the data's information. We don't have the totals of any column or row. You have what you have here. In this situation, they took a poll and they determined of the cars that were parked on campus, they wrote down whether they were from a student or a staff member, whether they were an American-made car, a European, or an Asian-made car. Those were the makes of the cars. And they simply wrote down the totals of each category in the way that the rows and the columns overlapped. But in order for us to do some of these calculations, one of the first things I really like to do is to look at the rows and the columns and to go in and find the totals of each of these rows. And so one of the things we can do really quick is we can fill in these row totals. And let's see, we have for American-made cars, there were 212. For European, there were 45. And there were 102 for the Asians. Now, if I add those values together, I'm going to get the entire total for the whole table, which would be 359 people or cars were involved in this survey. There were 195 students and there were 164 staff members. Now, this is relevant when I go to ask these questions or answer these questions at the bottom. If I know these totals, right, these marginal values, that's important for later on, this is really going to make my job a lot quicker. What percentage of all cars, this is really important. When you're reading these questions, the most confusing thing about this is they can ask a few questions and they're going to change the population of interest. Right? Am I looking at the whole group or am I looking at a subset of the group? In this case, they wanted to know the percentage of all cars. That's everybody. That's out of the 359 people, what cars were foreign? Well, we are in America, in the USA, so our foreign cars would be anywhere from European or if they were Asian-made cars, right? So I would want to know the total of the non-US made cars, right? And so we would add you'd add 45 plus the 102, and that would get us 147 out of the 359 cars would be foreign made, or 40.95% approximately. Okay, now the next question asks, what percent of the American cars were owned by students? Notice what they did. They want to know about the American-made cars. So what we've done here is we've really changed the description. We've changed our totals, and we've decided to go with just the American cars. So they've put what we would call a condition on the group you're looking at. In order for us to consider this group, we are looking at just American cars, right? And so we know that there are 212 American cars. So whatever I end up doing, it's going to be out of 212. And this one, they wanted to specifically look at the ones that were owned by students, okay? And so we know that students, there were, out of the American cars, 107 of those were owned by students. And so we would say it's 107 out of 212, and that's going to get us about 50%, a little more than 50%, so 50.47%. Go to 2 decimal places when you're writing the percentage, or 4 decimal places if you're writing the proportion, the decimal value. The next question is, what percentage of students owned American cars? Notice back, now we're identifying another group, right? We're saying, okay, we want you to look at just the student systems, right? So now we're looking at the column. So out of these 195 people, how many owned American cars? Well, that's easy enough. We know that there were 107 out of the 195. Out of the 195 students, 107 of those owned American cars. And so that's going to be about 54.87%. Okay, vocab. What is the marginal distribution of origin? So earlier I mentioned that the tables, or the totals we did, these are our total values, right? But they also occur in the margins of my table. And so we would consider these the marginal values. Now, they're being very specific. They're not looking at just all the margins. They want us to look at of origin, right? So if I take origin, and I would like to know out of the different values for origin, what percentage do they take up, right? So 212 out of 359, 45 out of 359, and 102, because there are those many values or those many cars in the total group. So this is going to be requiring me to choose three different colors, or not three colors, three different values, right? So if we come over here, we're going to say, well, there were 212 out of 359. This would be for American. We had 45 out of 359. This would be European. And then we had 102 out of 359 to be the Asian cars. Okay, and we can convert those into percentages. Approximately 59% for American. European had 13%. And then it was 28% for the Asian. Okay. And here's something important. When I'm writing out something like this and there's multiple answers, I need to make sure that I clarify which one's which. If I had written down the percentages here, then I wouldn't have gotten full credit for an answer like this, because I'm not clearly identifying which answer is which, right? So make sure that you do that. Don't make your reader or your grader make that decision for you. They may get it wrong. Okay, next one. It says conditional distribution. Now, what are the conditional distributions of origin by driver classification? Now, they've gone here and they've talked about conditional distribution. So I'm changing up something. I want to know how origin is distributed among a certain condition. And that condition is by driver classification, right? That's this value here. So they want to know, how is it broken down for students and staff members for the American and Asian cars? Now, this one, I'm going to have 6 different answers, because they want to know for both of the classifications, right? So if we go ahead and we set that up, we're going to say driver, and we'll do it in kind of the same way: American, European, and Asian. It's easy to kind of put this into a table, so we're just going to kind of write the percentages down. But this time, I'm going to go ahead and I'm going to just kind of go straight to the percentages. So we're going to put students first, just like the table is, and then staff. And so in this example, we're using the totals for students, right? And so students would have 107 out of 195. So for American students, you're going to have 107. Let's kind of zoom in here. 107 out of 195. European is going to be 33 out of 195. And then Asian is going to be 55 out of 195. For staff members, the same kind of thing. It's 105 out of 164, 12 out of 164, and then 47 out of 164. And so, and I can go ahead, I can write these down as a percentage. I can leave them as fractions. All of these things are all all great ways to write your answers. Okay, a lot of the time you're going to go straight to the answer and write it as a percentage. I wanted to kind of give you an idea here of what it is, how you wrote it down. So I'll just recopy the percentages over here. So for student, 107, let's see, what was that? American students was 55%. For European for students was 17%. And for Asian, it was 28%. Keyword here, when you add up your values, you should get 100%. Now, give or take, if there's a little bit of round off error and you don't get 100% for the totals here, that's okay. Here we didn't really round a whole lot. Okay, and for staff, we would end up getting similar results, but for staff, American would be 64%. We had 7% for European and 29% for Asian. Okay, and here again, we're still getting 100%. That's just a good way to double check that I didn't make any silly mistakes. A lot of the times you can definitely do that. Now, last question. Do you think that the origin of the car is independent of the type of driver? We have a number of ways to do this. If we think that it is independent, then we can create the conditional distribution of origin by driver, which is what we just did in part E. I'd like to look to see, are the cars distributed the same way among the students and the staff members? If they are, then if I were to go out to a parking lot and look for an American car, then the driver would be independent of the origin. In other words, it doesn't matter. The same percentage of students and staff members drive American cars. And we can clearly see that for American and European, it's clearly different. You might be able to talk about for Asian, it's really similar. So it may not make a difference for that particular car. However, if I'm looking at this in general, all of my percentages need to match up. And in this example, because they are different, they are dependent. All right, that's an easy way to remember it. If they're the same, they would have been independent. I can also look at this. I can also look at of my if I wanted to talk about just in general, I could figure out what percentage of cars were owned by Americans. So 212 out of 359, and look at what percentage of students drove American cars, right? 107 out of 195. If those two fractions are not the same, and they're not, then if the conditional does not meet the marginal, then you also have a way of showing that it is not independent. It is dependent, right? Same way here. They'd kind of set you up here by doing the conditional distributions and seeing if they're the same across the board. And in this example, they do not meet up. So we would say because they are different distributions, they are dependent. The two variables we're looking at, origin and driver classification, would be dependent. Hope this helps. That part, the independence part, is probably one of the more complicated pieces. Make sure you spend a little bit of time going through and determining how you can determine if variables in a two-way table are independent or not. I'll see you next time.